Okay, class, let's talk about dividing mixed numbers today. Just like with multiplying mixed numbers, dividing mixed numbers has a little rap to go with it. It goes kind of like this. To divide fractions, don't ask why, just flip the second and multiply. And that's really all we have to do with division. But you'll notice in division, we do basically the same thing that we've done with multiplication. The only thing we can divide is fractions. The only thing. So that means we've got to change things to fractions first. So if I have a mixed number, you need to use your popcorn method in order to change it to a improper fraction. If you have a whole number, you put a 1 underneath it. Now what I'd like to do is I'd like to have one of my classes demonstrate our fraction wrap. So if you will listen, you will be amazed. And that is our multiply and divide wrap. Okay, so let's see if we can do a few questions. Here's the first one. It says 5/8 divided by 4/7. Well, the first thing that we look at because of that wrap is, do we have fractions? And in this particular problem, we do. Okay, so we just have 5/8 divided by 4/7. But what does our rule say? To divide fractions, don't ask why, flip the second. So we're going to take this and we're going to flip the numbers. So we're going to make it as 7/4 and then change it to multiply. The 4/7 and the 7/4, we call those reciprocals, because if you were to multiply those together, you will get 1 as a value. Now, we look at our problem here and we ask, can I simplify anything? Can I simplify any top with any bottom? And in this case, we can't. But we're very tempted in this original problem to simplify the 8 and the 4. But there's a standard rule that applies. You can only simplify if it is multiply. So now that we have the multiply problem, we can't simplify. All we do is go through the multiplication wrap. To multiply fractions, I know I got them. It's top times top, bottom times bottom. So 5 times 7 gives me 35. 8 times 4 gives me 32. Now, right now, you can't leave your answer as an improper fraction. You must simplify it to a mixed number. So we ask ourselves, how many times does 32 go into 35? It goes 1 time. So if I take 32 out of the 35, what do I have left? 3, and they're of all size, 30 seconds. So our answer would be 1 and 3/32. Now, what if you had 2 mixed numbers? Well, if we had 2 mixed numbers, our rule says to divide fractions. The only thing I can do is fractions. So I have a method that I can turn this into a fraction, where I take the 3 multiplied by the 5, add the 1, and put it back over the 3. We call that the popcorn method. So 3 times 5 is 15, plus 1 is 16 over 3. Now, since this is a division problem, I know I'm going to be flipping the fraction. Once I get this, I'm going to flip it to put it into this multiply problem down here. So what I like to do to prevent careless mistakes is I change this to an improper fraction. 5 times 3 is 15, plus 1 is 16 over 5. And I like writing it right above that, or right up beside the mixed number right there, so that whenever I bring it into this multiply down here, I know to flip it. So it was 16 over 5. I'm now going to write it as 5 over 16 in my problem. And it changes to a multiply problem. Now we ask, do I have anything that I can simplify? Yes, I do have 1 top and 1 bottom that can simplify, the 16s. And I can divide them both by 16. So this 16 turns to a 1. This 16 turns to a 1. I don't have anything else to simplify, so now I multiply. 1 times 5 is 5. 3 times 1 is 3. And again, we simplify that down to how many 3's in 5? 1. How many is left over? 2. And they're all thirds. So 1 and 2/3 is my answer. Well, let's try another one. Let's try another one here. So now what about a whole number? Well, if we have a whole number, again, it's not a fraction, so I have to turn it into one. And the way we turn a whole number into a fraction is we simply put it over 1. So now I take the mixed number, I change it to an improper. So 6 times 5 is 30, plus 5 is 35 over 6. So when I put it into the problem down here, it's 6 over 35. And we multiply. Now this one, it's a little tougher to see what can simplify, but we do have a 14 and a 35 that share a 7 in common. So I can divide this 14 by 7. It turns out to be 2. I can divide the 35 by 7, and it leaves a 5 behind. So there's nothing else I can simplify. Now you're going to try to simplify this 2 and this 6, but because they're both on the top, we can't do that. You can only simplify a top with a bottom. So now I take the 2 and the 6, I multiply those together to get 12. The 1 and the 5, because those are what are left on the bottom, to get 5. And now we simplify. How many 5s in 12? 2. 5 times 2 is 10, so I take 10 out of the 12. I'm left with 2/5 as my answer. So 2 and 2/5 is my final answer. Now, what if I threw a negative on there? Does that make any difference? No, it doesn't. It just tells me that my final answer is going to be a negative, because here we've got one negative makes it negative. If both of them were negative, then my answer would be positive. So we take this one, we change it into an improper fraction. 4 times 5 is 20, plus 1 is 21 over 4, and it's negative. This one's already a fraction, so I don't need to do anything to it, but I do have to flip it to turn it into the multiply part. So this 5/8 becomes 8 over 5. And now it's multiply. Now I know my answer will be negative because of the one negative. Now, do I have anything that can simplify? Yes, I do. The 4 and the 8. They can divide by 4. So the 8 turns into a 2. The 4 turns into a 1. So now when I multiply across, I get 21 times 2, which is going to be 42 over 1 times 5, which is 5. So now when we simplify this, we ask how many 5s in 42? Well, there's 8 of them with 2 left over. So 8 and 2/5. One negative makes the whole thing negative. So we end up with negative 8 and 2/5. Simple as that. Now, in the real world, you're not going to be given a math problem like this. You're really not. They're not going to give you one of those. It'll be something more like this. So let's see if we can do this one. It says Lori is building a path in her backyard using square paving stones that are 1 3/4 feet on each side. How many paving stones placed end to end are needed to make a path that is 21 feet long? Well, the first question I ask about this one is what's important? What do we have? Well, we've got paving stones here that are 1 3/4 feet on each side. Okay, and we're going to lay them end to end, kind of if I were to do this as a picture, lay them end to end like that. Okay, so each one of these would be a stone. And I know that this entire length right here is going to be 21 feet. So I'm taking the 21 and chopping it up into sections of 1 3/4. So this becomes a division problem. 21 divided by 1 3/4. Because I'm chopping a 21-foot section up into 1 3/4 feet pieces. So now we do our math. 21 is a whole number, so it's 21 over 1. Okay, we'll make this into a fraction by doing 4 times 1 is 4, plus 3 is 7 over 4. So this becomes 4 over 7 in the multiplication problem because we flip our fraction. Now, do we have anything that can simplify? Yes. The 21 and the 7, they have a 7 in common. So the 21 becomes a 3, the 7 becomes a 1. So we're left with 3 times 4, which is 12, 1 times 1, which is 1. So overall our answer is 12. And now we've got to look at a label. When we come back to our question, it says how many paving stones could be placed end to end. So this will be 12 paving stones. That's more along the lines of what you will see in the real world. Now, if we wanted to turn this into a star problem, we could add one section to this. What if each paving stone costs $5.25? How much would it cost to lay this path? That would be a star type problem, multi-step. So that is how we divide mixed numbers.